This is video 1. When we talked about arrays, we emphasized the fact that an array provides you a multi-valued homogeneous data type, which means that with one variable you can hold many values, but all the values have to be of the same data type. And we call this an array. And we saw that we can declare an array, as you see here. And we said a couple things. We said the name of the array really refers to the full content of the array. In this case, we have 42 values that we can store. So the variable age by itself means all 42. But age can be viewed as 42 values, but also 42 variables. And the names of those variables for an array are the name of the array followed by a subscript, where a subscript must be an integer value. So the 42 variables are age sub 0, age sub 1, up to age 41. And all of the 42 variables have the same data type. So let's take a look at a problem that we have solved before, the problem of students. Notice that we have 5 pieces of data for every student: a year, a last name, first name, average, and grade. So if we want to process 3 students, we need to have each of these variables for each of the students. So we will have a lot of variables here. And we have seen that we can read the data for the variables and calculate the average. We've done this in a previous assignment. So if we were to run this, we would get average of 87. All right? You have to trust me on that. And I want to introduce to you the notion of a heterogeneous data type. And here's the example. We have, if you look at this as a spreadsheet, you have column headings, and within the column, all the values are of the same data type. So it's like the column heading pretty much represents the variables that constitute the data for a particular entity. For example, the first row, let's call it first, has 5 values associated with it. The row called U has 5 different values. So we can declare such a data type by using the struct statement. And struct gives you a data type, not a variable, but it says I want a data type called student, and I want the data type to consist of 5 different variables. 1 is an int, 2 are strings, 1 is a float, 1 is a char. And let's talk a little bit. The value in the average column for next has a name. It's called next.average. So instead of using a subscript to identify things, we use a period or a dot. And the dot allows you to select which field you're talking about. So let's get some terminology straight. These columns here are called fields. The complete collection of data, all the fields, for a single entity, in this case called T, we call that a record. So a record consists of many fields. Each field can have a different data type, and each field has a name. So what is this variable here? Well, the name of the variable is last, and the field that we want is the year field, so the name of the variable is last.year. So here's some examples. I can declare a variable called u of type student, which means it has 5 pieces of data: a year, last, first, average, and grade. And we can initialize it in a similar way as we did with arrays. We can provide a list of values. Notice that in this case, the values may have different data types. We can declare a variable called first, or a record called first, that does not have a data type, that does not have initialization. And we can initialize the fields one at a time. Set the year field to 4, last name to Abel, and so forth. We can also read values in. So we can read values using the variables. You cannot say, if you say cn greater last, that won't work, because cn, the greater operator, only works for basic data types. So if you have a variable that has many data types, then you got to read each field individually. All right. Let's take a look at what our program would look like if we go to using a record. We're defining a data type, student. Notice that the data type declaration is global, so we put it above the main so that the main can have access to it, and any functions you have can have access to it. So we declare, and now we need 3 variables, 3 records called S1, S2, and S3. What about S1? S1 has all 5 of these variables associated with it. So how do I read data for the students? Well, for S1, I read the year field, the last name field, and so on. All right? So with this, we are going to do the same calculation we did before. So if we run that, let's see what we have. We get the same answer. Okay, so let's summarize a couple things. One is the struct statement is like the enum statement. It allows you to create a data type. The syntax is the word struct followed by data type followed by a block. And notice that the block ends with a semicolon. Inside the block, you just have a list of declarations where you're declaring each field. Okay. In C++, fields are called by various names. One such name is called member data. So the data type has data members: year, last name, first, average, and grade. With that, we've done our first video on structs. We will come back and show how to use structs with functions.